Most people trying to break into cloud are learning AWS completely backwards, right? They assume that there is some sort of invisible line. Once they've learned enough services, pass enough certifications, and watch enough tutorials, they'll finally feel ready to apply. But that line, right, it just keeps moving, right? Because you finish one course and discover three more things that you apparently need to learn. You pass certification, open a cloud engineer job description, and you still feel very much underqualified. You build a project with a tutorial, you put it on GitHub, and then you realize you would struggle to rebuild it. Or explain why it was designed that way without even opening the steps again. And this is very frustrating, especially if you already work in IT. At work, people trust you, right? You can handle the queues, you can troubleshoot the systems, and you can solve the problems that people give you. But when it comes to AWS, you somehow feel like you need to start your entire career again. So you just tell yourself that I need to learn a little bit more before I apply for jobs. And then another 6 months disappear. Right. The truth is, you don't need to learn all of AWS at once. You just need to become competent in 7 specific capability buckets. And I've ordered these around how an employer experiences your abilities, not around the order an AWS course will teach the services. Skill 1 makes what you already know legible. Skill 2 proves that you can think like a cloud engineer. And the remaining 5 prove that you can choose, connect, secure, automate, and operate a real AWS system. I'm Sulaiman. I've been in tech for more than 11 years, and I've spent more than 7 of those working with AWS across cloud engineering, architecture, DevOps, and consulting. Now, through my Cloud Engineering Academy, I've helped more than 900 IT pros, engineers, and career switchers develop practical cloud skills that they need to pursue cloud engineering roles. And when somebody has been studying AWS for months but still feels stuck, the problem is rarely that they have learned absolutely nothing. The problem is that their knowledge is actually scattered. There is no boundary around what matters, no clear test for whether they can use it independently, and no reliable way to make that capability obvious to an employer. And if you're fitting all of this around a full-time job, a commute that you have to do, or family that you have, that boundary is really important, because another 6 months of unstructured studying is not free. It costs you evenings that you don't get back, while the applications keep getting pushed further and further into the future. So these are the 7 skills that I would focus on. And to be clear, no honest person can promise that these 7 skills actually guarantee you a job, right? Your location, the role, the market, the applications, and your interview performance still matter a lot. So when I say the only 7, I mean 7 capability buckets that give your learning a boundary, right? It's not a magic 7 box that you tick before a company actually gives you a 6-figure job offer. So without further ado, let's start with skill number 1, which is technical communication and career translation, right? And I've put this first very deliberately, because being capable and being recognized as capable are 2 different things, right? Because you might already investigate incidents, manage access, troubleshoot networks, document changes, or keep systems running in your current IT job. But if your CV reduces all of that to just resolves tickets, or your interview answer becomes a 5-minute list of AWS services, the employer will never actually see the judgment underneath the work. Your project does not speak for itself. Your years in IT do not automatically translate themselves into cloud experience. So you have to make the relevance very, very obvious without exaggerating what you did. And this is a fine line, right? Because clear communication starts with clear thinking. You want to start with the answer, then give the minimum context, and then the decision that you made, the trade-off that you accepted, the evidence that it worked, and why it matters for the role. So you want to think in answer, context, decisions, trade-offs, evidence, and relevance. And you must know your audience, right? A recruiter needs the problem, your contribution, and the outcome. The engineer that you speak to will want the implementation detail, the alternatives, and the failure modes. A hiring manager will be listening for ownership, judgment, and whether they can trust you around a real system. So the test is whether you can explain the same project in 90 seconds to a recruiter, in 5 minutes to an engineer, and then answer again when one requirement changes. So if your mind really goes blank when people ask you these questions to discuss and share and communicate your experience, do not hide the gap in ability with technical jargon, right? Don't just start saying technical buzzwords. You want to go back and organize the thinking. Cool. So number 2 is architecture and judgment. Communication makes your capability visible, but architecture reveals how you actually think. Architecture is not dragging AWS icons onto a diagram. It's taking an ambiguous business problem and designing the least complicated system that solves it. Let's say an online shop crashes whenever it runs a promotion. The company has a small team, it has personal customer data, and a limited budget. What actually needs to scale? What must remain private? What happens when a component fails? What can a team realistically maintain? Where would spending more reduce meaningful risk? And where would it only add complexity? The truth is, there's never ever a perfect architecture. There's always trade-offs, which means that there's only an architecture that fits the current constraints better than the other alternatives. This is why scenario-based interviews catch so many people out, because people that go through interview processes and they learn on their own, they memorize a very specific diagram, like a highly available AWS architecture. Then the interview changes the budget, the traffic, the security, the requirements, or the team capability, and then the answer will basically fall apart. So the test is whether you can design from a blank brief, explain the important trade-offs, and adapt when one requirement changes. Skill number 3 is AWS service judgment, knowing what to use and why. Now, most people study AWS services as specific definitions. EC2's virtual server, S3's object storage, Lambda runs code without you managing a server. That is fine, but that is recognition. It's not engineering judgment. The real skill is looking at the requirement and deciding whether the workload should run on EC2, containers, or Lambda, whether data belongs in RDS or DynamoDB, whether the system needs a queue, and then explain what you gain and what you give up with each architectural decision. One thing to know is that you do not understand a service because you can define what it is. You understand it when you can explain when you would use it, when you would not use it, and why it fits this particular problem. Take one requirement, design 2 viable solutions, and defend why you chose one over another. And if you only know one route because that is the route that the tutorial showed you, then you know this is one of your gaps. Skill number 4 is networking. Networking is the connective tissue of almost every AWS architecture and one of the fastest ways to expose whether somebody understands a project or simply recognizes diagram. Here we need to understand IP addressing, VPCs, public and private subnets, route tables, internet and NAT gateways, security groups, DNS, load balancing, and how one request moves through an entire system. If a user opens your application, can you follow that request from the browser through to the network, through to the application, into the database, and then all the way back? If it cannot connect, can you determine whether the problem is a DNS issue, a routing issue, a port issue, a security group issue, or the application itself? If you cannot follow one request through an entire architecture, you do not yet understand the system. You just recognize the icons. Got it? Number 5 is AWS security. A project can work perfectly and still be very dangerously insecure. From the outside, the secure system and insecure system can look identical until somebody actually finds the gap. So here we really need to understand IAM roles, policies, least privilege, secrets, encryption, audit logging, shared responsibility, and the blast radius. So here we're asking the questions such as, who can access this resource? Why do they have the permission? Where are the credentials stored? If those credentials leak, what can the attacker reach next? Now this matters even more now that people are using AI to generate Terraform and policies that they don't understand. AI can make the deployment turn green, but it cannot take responsibility when the permissions are wrong, right? The test here is not, did the project deploy? But the test that we have to put ourselves through is demonstrate an allowed action, a denied action, and explain how the design limits the damage if one component is compromised. Number 6 is infrastructure as code and automation. When you're first learning AWS, clicking through the console is useful because it helps you see what each service does. But in real engineering environments, infrastructure needs to be repeatable, reviewable, version controlled, and also changeable. That means we need to use Terraform or CloudFormation. We need to use Git. We need to use Bash, Python, right? We need to use variables, state awareness, automation. So can you destroy the environment and rebuild it from the repository without relying on the undocumented console steps? If you cannot rebuild the infrastructure without remembering where you clicked it, you basically just have a demo, right? You don't have a reproducible infrastructure. And if AI wrote the Terraform, can you change the requirements? Can you review the security? Can you fix the errors? And can you explain what every important block is doing? Number 7 is cloud operations and troubleshooting. Getting the green tick is not the end of a cloud engineer's job. is usually when the real work begins. You need enough Linux deployments, logging, monitoring, health checks, CI/CD, troubleshooting knowledge, right, to operate the real infrastructure after it's been built. This is also where those of you already working in IT support, systems engineering, networking, or infrastructure have far more transferable experience than you think, because you already know how to investigate symptoms, check evidence, isolate a problem, escalate when necessary, and restore services. The missing piece is applying that knowledge in those disciplines into AWS and then describing it as engineering evidence rather than just support, right? So build the project and then deliberately break it. So here, the test is not whether you can make the deployments turn green. Everyone can do that. It's actually whether you can explain whether it turned red and recover it without restarting the tutorial. So now look at what happens when you combine all 7 skills. Take one online business that needs a customer-facing application which can survive a promotional traffic, protect personal data, remain affordable outside peak hours, and be operated by a small team, right? Think about this case study. Your job here is to explain the problem, so your contribution and its relevance to both a recruiter, an engineer, and a hiring manager. You want to design the architecture and defend the availability, the cost, security, and maintainability, right? The trade-offs. You want to choose and justify the AWS services. You want to design and troubleshoot the complete network path. You want to implement least privilege access and data protection. You want to create everything through Terraform and Git. Then you want to deploy it, monitor it, break it, diagnose it, and recover it. Now, something to really understand is by having one project that you actually build end-to-end and finish it is worth way more than 50 different unfinished projects, because one project like this will teach you way more about your actual job readiness than 7 disconnected tutorial projects, or even, like I said, 50 projects that you've built that you can't explain and you haven't finished. Because now you're not just proving that you've completed something, you're proving that you can explain, you can design, you can choose, you can connect, you can automate, and you can operate. So here is what I want you to do. I want you to assess yourself. For each skill, ask, can I only recognize it? Can I reproduce it with guidance? Can I do it independently? Can I adapt it and defend it when the requirements change? Do not add everything together and give yourself some sort of fake higher ability percentage. Find the lowest capability that blocks the role that you're targeting or causes the integrated project to fall apart. That is how you focus on your next learning priority, right? Not the newest AWS service, not another random certification, right? We want to really focus on our gaps and then prioritize those gaps and really work on that, right? And then you go on to the next one. So really go and map out what you know, what you don't know. Can you recognize it? Can you reproduce it? Can you do it independently? Can you adapt and defend it across all 4 skills, right? And then you know, yes, I can, no, I can't, right? And then you go from that. Now, if you're still exploring whether cloud is the right fit for you, take these 7 skills and use them to build your first serious project. But if cloud is already your direction and you've taken real action through AWS studies, certifications, projects, IT or DevOps work, applications, or even interviews, and you cannot secure a job and your effort is still not turning into confidence or interviews or even offers, use the 7 skills as a diagnostic. But if you can point the exact place where your progress breaks down, then this is the kind of gap that we help identify and correct inside of my Cloud Engineering Academy. You can use the link below to apply for a diagnostic call with my team. We'll look at what you've already studied and built, the roles that you're targeting, and whether the bottleneck is your technical foundation, your architecture, your project proof, your positioning, or your interview explanation. And if we are the right people to help you, then we'll explain how the Academy works and the options that we have available. If we're not, then we'll tell you that as well. But either way, you want to stop asking, what AWS service should I learn? You want to ask, can I explain it? Can I design it? Can I choose it? Can I connect it? Can I secure it? Can I automate it? Can I operate it when something goes wrong? Those are the 7 AWS skills to get hired as a cloud engineer. As always, I'm rooting for you. Good luck and become undeniable.